Welcome to the math class today. Today, what we're going to be talking about is we're going to be talking about solving system of equations. So, how are we going to do that? Or systems of linear equations, rather. Now, first, I'm going to give you one question, and then I want you to try to solve that first. Solve 2x minus 7y equals 9, and x plus 3y is equal to 4. And what would be the value of x and y? So let me just throw this one at you first, and then let's see what happens. All right, I'm sure you spent enough time to solve this one. So what I'm going to do is I'm going to try to find the value of x and value of y individually. The way in which we're going to do it is maybe in the first equation, first time, this is since 2 to 1 ratio. What I'm going to do is I'm going to make the coefficients of x the same. So I'm going to multiply the second one by -2. Then what do you end up getting? Okay, so this one is equal to -2x minus 6y equals -8. So what I end up what I end up doing is when I add up these two equations, I'm getting -13y equals 1. Hence, y becomes -1/13. So as soon as we get that one, we should be able to figure out the value of x. We can put this one in place of y and then figuring out the value of x. Let's just finish that up then. Borrowing this equation, x equals, or maybe x plus 3 times -1/13 equals 4. So then you get to realize that x equals 4 plus 3/13. Now, then this one is equal to 4 can be expressed as 52/13 plus 3/13. Hence, we get 53/13 becomes our answer. That's what x is equal to. All right, but we're going to revisit this question later on. But for now, what we're going to be doing is this. All right, so that's correct. That's how we can do it. Then, what if I had to give you this question? Let us say solve. I'm going to give you a more general question here. Ax plus by is equal to f. And then cx plus dy is equal to g. So I'm just giving you two equations, very general, a, b, c, d, and then f and g becomes some sort of constant. And how do you find the value of x's and y's? Value of x and y. So I'm going to give you a little bit of time on your own for you to think about it first. Great. I'm sure you spent a lot of time. If you didn't, you can still pause it and then solve it and then try to compare the answers with me later. Now, the way that I'm going to do is, just same thing as before. I'm going to cancel out the x's here. How are we going to do it? By multiplying the top one by -c, bottom one by a. Then what I end up getting is -ac x minus bcy equals -fc. Bottom one, on the other hand, is acx plus ady equals ag. All right, so when I combine them together, you can see that these two cancels away. So I can factor out y as well. Then what do we have here? AD minus BC. And then this one is AG minus FC. Then you can see that y should be equal to AG minus FC all over AD minus BC. Okay, we got the answer. So we can close up at this point because we know the value of y. But when you think about it a little bit more, you get to see something quite interesting. Let's look at the bottom one first. Wait a minute, AD minus BC. That looks quite familiar. That's right. That was the formula for determinant of 2 by 2 matrix, where A, B, C, D is where A, B, C are the elements of the matrix. But in fact, that's the coefficient matrix of these equations. So in other words, denominator can be expressed as determinant of A, B, C, D. All right, that's it. Then AD minus BC. Oh, but wait a minute. The numerator seems to be very similar as well. Instead of D, I have G. Instead of B, I have F. So in fact, it's the same thing as A is A, and then C is a C. Same as you can see. In place of B, I have F. In place of D, I have G. In fact, Y can be found in this way. That's very interesting because ABCD is literally the coefficient matrix, and my numerator is AC stays as it is, but instead of the coefficients of Y, keeping it as they are, but that they were replaced with FG. All right. Then, how about X? How do you find the value of X? Okay, then value of X. What I'm going to do is, then in that case, I'm gonna get rid of Y's, right? So if I have to get rid of Y's, what I would end up getting is I'm gonna multiply the top one by negative C. I mean, top one by D, and then bottom one by negative B. So in other words, top one by D, and bottom one by negative B. Then what we end up getting is a dx plus b dy, equals FD. Now, second one is negative BCX minus B dy is equal to negative GD. All right. When I combine them together, these two cancels away. Okay. So we have, once again, X can be factored out, and we get AD minus BC. How about that, huh? That's the same thing as before, where it becomes a denominator of the Y value, and that's equal to FD minus GD. I mean GB rather, because we multiplied by B here. All right. So then we get to realize that X must be equal to FD minus GB over AD minus BC. Wait a minute. And this can be rewritten as denominator is still the same as before. Determinant of ABCD matrix. And the numerator is, you can see that D is okay, B is okay, but in place of A, I have F. In place of C, I have G. Wait a minute. In case of X, still the determinant of the coefficient matrix, but instead of B and D coefficients of Y were the same, but instead of coefficient of X is A and C, we replaced it with FG. Ooh. Wait a minute. Does that work with our previous question? Let's try to check it out. Our previous question was 2x minus 7y. So then, what is x equal to? The coefficient of 2 and 1 will be replaced by 9 and 4. But coefficients of y stays as it is, negative 7 and then 3. Denominator was just a regular coefficient matrix, so 2, negative 7, 1, and then 3. All right, let's look at it. So this one is what, 27 minus negative 20, 8. Oh, actually, this one's supposed to be 55, my bad. Yes, we found a mistake here. It was what, 55. How about the bottom one? 6 minus negative 7 becomes 13. Oh, we got that one right away. How nice. How about the second one here? So y, based upon the this matrix operation, y is equal to, then what do we realize here? Denominator is the same. 2, negative 7, 1, 3. My numerator is, x values stays as it is, 2, 1. But instead of coefficients of y, we're going to place 9 and 4. Then we get 8 minus 9, negative 1. And denominator was 13. We figured it out earlier. Oh, it matches right away. And in fact, so what we have done here is Kramer's rule. So Kramer's rule is a way for you to find the solution of the system of linear equations. So in that case, when we have a, b, c, d, ax plus by equals f, and then cx plus dy equals g. And then what we end up doing is x is the matrix where coefficients of x has been replaced with these results. So fg bd of the determinant of that. The denominator is a determinant of the coefficient matrix, so a, b, c, d. But many times what we end up doing is, since I don't want to write all these things, and in fact, and then Kramer's rule applies not only for 2 by 2 system, but 3 by 3, when you have 3 variables or 4 variables as well. So what we end up doing is, on the top, we just write down determinant where x has been replaced over determinant of the original coefficient matrix. Then the y becomes determinant where y coefficients are replaced over determinant of the regular coefficient matrix. That's basically what we can do. Then let's do one more question here, guys. So can you find the value of x and y using the Kramer's rule? All right, I'm sure you finished it already. Very nice. So let me try to do this one with you. So what should be the value of x? X is equal to, 7, 4 is replacing these two. So 7, 4, and then 2 and negative 1 over 6, 3, and then 2 and negative 1 is given in this way. So in this case, negative 7 minus 8 becomes negative 15. Denominator here is what? Negative 6 minus 6, so negative 12. I can divide the top and bottom by 3. Then I get 5 over 4 becomes my x value. How about my y value? My y value now is coefficients of y has been switched with the results at the end, and then we have 6 to 3 and negative 1. Then my numerator here becomes, this is 24 minus 21, so we get 3. The bottom one was negative 12, so we get negative 1/4. So those are the values of x and y. Relatively simple. What if I had to give you 3 by 3 equations? So then how would you do it? Finding the determinant of 3 by 3 matrix is, I mean, you can do it, but it's not that, rather quick. So I'm going to use a calculator in this case. We'll talk about how we could have done it. 2x plus 3y minus z equals 1, and then 4x minus y, or rather plus y, and then minus 3z equals 11. And thirdly, 3x minus 2y plus 5z equals 21. Now, using the Kramer's rule, how would you be able to find the value of x, y, and z? In case of x, determinant where x has been replaced, divide by determinant of the coefficient matrix. That's basically what I'm looking for. So I'm going to take out my calculator here. So you can take out your calculator as well. So let me just bring this one up, bring this one down here. Okay. So what I'm going to do is I'm going to go for the matrix. So second matrix, and I'm going to edit it. Let me just do the A. And this will be 3 by 3. And then what I end up getting is, coefficient matrix. So we're going to be using that over and over again. So it's going to be 2, 3, negative 1, 4, 1, negative 3, 3, negative 2, and then 5. Alrighty. And I'm going to quit. And I'd like to get the determinant of this. So I'm going to go for second matrix. I'm going to go for math and determinant. That's what I'm looking for, number 1. And second matrix. Yes, I want to get the determinant of A. Then it tells me that my value is 78. So this one is equal to 78 on the bottom. I think it was negative 78. All right. How about my numerator? So 2, 4, 3 has to be replaced with 1, 11, and 21. So I'm going to edit that right now. Second matrix. So it's going to be 1, and then 11, 21. All right, all the other things are the same, so I'm going to quit. Go back up. Determinant of A one more time was negative 3, 12. So when I divide, this one divide by, I get 4 as my answer. So x value is equal to 4. Why don't you try to find the value of y and z? All right, go ahead. I'll wait. All right, so now let's look at the value of y. So in order for me to get the value of y, it's going to be this one. So what we end up getting is I'm going to edit the matrix one more time. It was 2, 3. Oops, actually, y has to be replaced. So it's going to be 1 here in place of y. Instead of 11, we got to keep 4. And then 11 has to be in place of this one. Okay. And then we got to have 3. And we got to have 21 replacing negative 2. Alrighty. Second quit. And then I'm going to find the determinant of that one once again. It's 156. So then this one is 156 over negative 78, which makes it to be negative 2. And how about z? Then you should be able to figure out z as well. Oops. Okay, just regular determinant of the coefficient matrix, negative 78. Let me try to figure out the numerator here. So then, second matrix, oops, no, that's not what I'm looking for. So second matrix, edit. It was 3, and then z value, z component has to be replaced with 1. 4 is good, and then it should be 1, and then it has to be changed to 11. 3 was good, it was negative 2. The last one should be 21. Alrighty, I'm going to second quit, and I'm going to figure out the, oh, it's negative 78, okay. Then I get 1. So 4, negative 2, and then 1 was my solution for this set of equations. Alright, so we're going to stop here, and I hope you enjoyed Kramer's rule, and I'll see you later. Bye-bye.